Welcome to part 2 of the lecture series on order of operations and writing a numerical expression. In this section, we will write numerical expressions. We will now consider writing a numerical expression given a phrase. Recall that a numerical expression is an expression involving numbers and arithmetic operations. When we say we will evaluate or simplify a numerical expression, that means we will determine the value of the expression by performing the operations involved. We will start with an example. Write a numerical expression for the given phrase, then simplify it. 5 less than the difference between 9 and -4. We interpret the first part of the phrase, 5 less than, as subtracting 5 from something. The second part of the phrase tells us to take the difference between 9 and -4. Recall that a difference indicates subtraction. Therefore, when we consider both parts of the phrase, we will subtract 5 from the difference between 9 and -4. So our numerical expression is 9 minus -4, and we subtract from that 5. Using the order of operations, we get 9 plus 4 minus 5. Again, using the order of operations, we get 13 minus 5, which gives us 8. Therefore, this simplifies to 8. We will now write the numerical expression for the phrase twice the product of -5 and 7 subtracted from -11. We may rewrite this expression as subtract from -11 twice the product of -5 and 7. Twice the product means we will multiply 2 times the product of -5 and 7. Recall that a product means multiply. Therefore, twice the product of -5 and 7 means that we will multiply 2 times -5 times 7. So to write the numerical expression, we start with -11 and we subtract from that the product of 2 times -5 times 7. Using the order of operations, we must multiply before we subtract. So from left to right, we will multiply 2 times -5 first, giving us -10. Then we will multiply -10 times 7, giving us -70. Therefore, we will have -11 plus 70, giving us 59. This phrase simplifies to 59. In our next example, we will write the numerical expression for the phrase the quotient of -24 and the sum of -5 and 3. Recall that a quotient means to divide and a sum is to add. So the numerical expression will be -24 divided by -5 plus 3. Adding -5 plus 3 gives us -2. Dividing -24 by -2 gives us +12. Therefore, this phrase simplifies to 12. We will now consider an application problem. Casey dives 35 feet below the surface of a lake. Her brother, Joey, dives 39 feet below the surface, but then ascends 24 feet. Find the vertical distance between Casey and Joey. In order to find the solution, we will first write the information that is given to us. We are given that Casey dives 35 feet, which can be represented by -35. We are also given that Joey dives 39 feet, which may be represented by -39. But we are also given that Joey ascends 24 feet, which is represented by positive 24. Note that since Joey first dives 39 feet and then ascends 24 feet, the numerical expression representing Joey's dive is negative 39 plus 24, and we are given that Casey's dive is represented by negative 35. In order to find the vertical distance between Casey and Joey, we must subtract the number of feet representing both of their dives. Distance is always positive, so we must take the absolute value of the expression. So the numerical expression describing the behavior of the two divers is negative 35 minus negative 39 plus 24, but we are taking the absolute value of that since we were asked to give a vertical distance. Using the order of operations, we will first perform the operation of addition, which is inside the parentheses, giving us the absolute value of negative 35 minus negative 15. We get the absolute value of negative 35 plus 15. Now I'm performing the operation of addition inside the absolute value gives us the absolute value of negative 20, which equals 20. Therefore, the vertical distance between Casey and Joey is 20 feet.